So far we've gone over the 5 different congruency theorems or congruency shortcuts, however we want to call them. And the ones that we had were side, 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 angle, side, angle, side, angle, 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 side. We had these 4. These are the ones that work. The ones that don't work were side, side, angle, and angle, angle, angle. These are the 2 that don't work. Those are the 2 that do not work. There is a special case that comes from side, side, angle that's called hypotenuse leg, which is saying if we have 2 triangles, 2 right triangles, and the hypotenuse and leg of one match up to the hypotenuse and leg of the other, then they would be congruent. But we're not going to focus on that because it's too specific of a case. It doesn't work every time. Well, it works every time for hypotenuse leg. Now, what we're looking at today is CPCTC. Now, you need to fix the note sheet because it says congruent, but it should be corresponding. So CPCTC, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So once we're able to say that the 2 triangles are congruent, their corresponding parts are congruent also. Or we just denote it as CPCTC, CPCTC. Congruent, corresponding parts of congruent triangles are congruent. So once we're able to say that the 2 triangles are congruent, then we can say all of their corresponding parts are congruent as well, because the 2 triangles are congruent. And that's what we're really going to be looking at today and using today, is CPCTC. Corresponding parts of congruent triangles are congruent. And to be able to use that, we need to first be able to say that the 2 triangles are congruent. Because if I can say the 2 triangles are congruent, then we can say that their corresponding parts are as well. So this is the first one that we're going to use. We want to be able to say or prove that QT, line QT, is congruent to line ST. Now, if I can show that the 2 triangles are congruent, then I can say that the 2 triangles are congruent to each other. Now, looking at this here, well, they gave us some given information. They said angle 1 is congruent to angle 2. And angle RTQ is congruent to angle RTS. This is our given information. This is just what we're told. And that's kind of helpful, because we have an angle and an angle here. Now, angle 1 and angle 2 really don't help us. Well, they're going to help us eventually, but them being just congruent isn't going to be one of our angles. Because I need to know that either these 2 angles or some more information. So it's going to help us eventually, but we can't just immediately say that they're one of our angles for our statement, because they're not inside the triangle. They're where? Outside. But I do know some other figures that are congruent. That's going to help if I have that. RT is going to be congruent to what? RT. Because we could call this the reflexive property, or it's just really, I'm going to say, it's the same line. It's congruent to itself. It's more the reflexive property of equality, or congruency, because not equality, we're not talking about 2 things being equal. But I'll call it same line. So we have a side and an angle, yes? we either need another set of sides or another set of angles. Well, most likely we're going to use angles because, well, they gave us this piece of information here. They gave us that angle 1 and angle 2 are congruent, yes? So we need to use that to show that these are going to be congruent. Okay. So we have the side in the middle, an angle. And if I can show that these two angles are congruent to each other, then we can be able to show that these two triangles are congruent by side angle angle. Well, I know that the measure of angle 1 plus the measure of angle RQT. These here make a straight line. So they would add together to be 180. And the reason I also know this is because they are a linear pair. We can also say that the measure of angle 2 plus the measure of angle, what would it be? Look back up here. RST. 4. And that's, again, a linear pair. So again, because they make a straight line, we can say that they're a linear pair. They add together to be 180. Now, since both of these add together to be 180, I can set them equal to each other. That's our transitive property of equality. And according to our subtraction property of equality, I can subtract 1 from both sides since 1 and 2 are the same. And really, I'm skipping a step because we'd have to substitute in one of these in here and then subtract, but really we know that these are the same, so we can subtract it from both sides. Yes? Which is nice because now I have a angle, a side, and an angle. And even though they're not in the correct order, really we have side angle angle, side angle angle inside the triangle that has been shown. Let me go back to the picture. A little farther. Because when we look at this here, I'm going to erase that. What we've shown is we know that this side in the middle is congruent to itself. These angles are congruent. And we can show, and we just showed that these two angles inside the triangle are congruent. So we're able to say that these two triangles are congruent to each other, yes? So this means we can say that triangle QTR is congruent to triangle STR by our what? Why can we say this is true? How do we know the two triangles are congruent? By our side angle angle. And since the two triangles are congruent by side angle angle, it means, well, we wanted to prove that QT is congruent to ST. The two sides we wanted to be congruent are congruent by our CPCTC. Because we went through that whole proof really to say that the two angles that are next to 1 and 2 are congruent to each other. So the two triangles are congruent by our side angle, which means the two sides we wanted to be congruent are congruent by CPCTC. Okay. Now, most of what we're going to be doing is not going to be as heavily proof-based as that one. So let's look at this one here. I think you'll like this one here a little bit more. So if we look at this here, explain how you can prove that angles C and A are congruent. Well, what do we know that is congruent on this figure? AB is congruent to what? BC. So we have what? Side, side. We have three sets of sides that are congruent, yes? So since we have three sets of sides are congruent, we're going to use all of this to say what? The triangle ABD is congruent to triangle what? CBD by side, side, side congruency theorem. Because we have three sets of congruent sides that match up in our two triangles. So it's by side, side, side congruency theorem, we can say the two triangles are congruent, yes? Well, since these two triangles are congruent, we can say that angle A is congruent to angle C by what? CP, CT. Corresponding parts of congruent triangles are congruent. And angle A and C are corresponding parts, so they are going to be congruent. Questions on this here? Questions on any of this here so far? Are we good with this here? So we really need to be able to say that the two triangles are congruent. Once we're able to say that the two triangles are congruent, we are able to show that the parts that we wanted to, angles A and C being congruent, are congruent as well. Any other questions on this here? So again, with CPCTC, we just need to be able to show that the two triangles are congruent, and once we do that, we can say that their corresponding parts are congruent as well. Okay, let's look at this one here. So we want to prove or show, be able to say that these two sides are congruent. Now we're told that QRT, that helps if I can have a marker. We're told that this angle here is congruent to SRT, this angle here. We're also told that RTQ, go in this direction, this angle here is congruent to RTS. Are we able to say that these two triangles are congruent? By? So let's see what we have. We have angle QRT is congruent to angle SRT. We also have that angle RTQ is congruent to angle RTS. So far I have an angle and an angle. So I need a side. Because when we think about all four of the congruency shortcuts that work, or congruency theorems that work with triangles, the only ones that have two angles, because we have side, 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 angle, side, angle, side, angle, 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 side. There's only two that have two angles. We need another side. We do not have a congruency shortcut that has three sides. We do not have a congruency shortcut that has three sides. So we need, or not three sides, three angles. Sorry. We do have one that has three sides, but we don't have one that has three angles. So since we were given two angles, we need a side. That's the only way this is going to work. Now, once we have this, we can say that triangle QRT is congruent to triangle SRT by our angle side angle congruency theorem, which means what? QT is congruent to by CPCTC. Corresponding parts of congruent triangles are congruent. Because once we're able to say that the two triangles are congruent, we can say any of the parts of those congruent triangles are congruent as well. Because again, the congruent parts, the corresponding parts of congruent triangles are congruent. Because for two triangles or two figures to be congruent, all of their sides and all of their angles must be congruent, or the corresponding ones must be congruent. Any questions on this here? Any questions over anything we've done so far? So really what we're doing is we need to be able to show that the two triangles are congruent. If we can, it's going to be either by angle, side, angle, 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 side, side, angle, side, or side, side, side. It's going to be by one of these four. If we can say that they're congruent, it means the other parts are going to be congruent as well because of our CPCTC. Any questions on this here, anything we've done so far? Explain how you can prove that angle W is congruent to angle G. GH, because it's told to us that this is a side. These sides are congruent. Well, we can just say angle U and angle H because there's only one angle there. We can use the vertex. We don't have to use three letters for those. So we have a set of sides, we have another set of sides, and we have an included angle in the middle. So these are going to be congruent by what? Side, side angle, side. Side angle, side. So because of this information, we can say that triangle WUV is congruent to triangle, so WUV, GHI would be the matching triangle, and it's by our side angle side congruency theorem, which means what? That angle W and angle G are congruent by what? CP, CT, C.
Where did you get that bottom part from the on the other side?
H. There's just a poorly written H. Any questions on any of this here? Any questions on any of the problems we've done so far? Are we good with this here? Any Okay. So looking at this here, I can say that these two angles are congruent because they are vertical angles. So looking at that there, we can say angle EDF, angle RDS or SDR, either one. Then we can say that RD is congruent to FD or DF. Mm-hmm. Well, we have an angle, a side, and an angle. Now, it wouldn't be angle, side, angle, because we have angle, angle, side, angle. So if I wanted to write this in the correct order, nope, not that. Really, these two would need to be flipped. This would need to be here. And we would say our side, RD, is congruent to DF. As this is by angle, angle, side. We have two angles followed by a congruent set of sides. Two congruent sets of angles followed by a congruent set of sides. Which this means our triangles, I'll say RDS, would be congruent to triangle. So RDS. This here would be FDE to follow the same order by angle, angle, side congruency theorem. So all this stuff led to this part here. And then from here, we can say what we wanted, which was that angle F right to angle R by CPCTC. Corresponding parts of congruent triangles are congruent. Any questions on any of this here? Any questions on any of this here so far? Are we good with this here? We'll look at this here. This will be the last thing we look at. I know there's one more. It's just really relating the same thing. But it's looking kind of a real-world application. Using the following method to find the distance across the river from point N to point P. So we place the stake at K on the near side. So that NK is perpendicular to NP. We have that. Find M is the midpoint. So the midpoint of NK. Locate the point L so that NK and LK. Explain how this plan allows you to find the distance. And M is congruent to NK, it is. So it'd be good if I had a pen. So we know that this angle here is congruent to this angle here, yes? So how would that be helpful in finding the distance across the river? Just across the river from point N to point P. How would that be helpful for finding this? All right, so these two triangles would be congruent because I have side, let's do it in different color. Because here I have an angle, a side, and an angle. Angle, side, angle, yes? So what that tells me, I'll write this underneath here, is that triangle LKM would be congruent to triangle PNM by our angle, side, angle, yes? Would you all agree with that? So measuring the distance from N to P, that would be difficult going across a stream, yes? But from this here, I know that NP is congruent to what? Okay. Go down a little bit. By our CPCTC. Would it be easier to find this than the other length? Yeah, we can find that length. So knowing that, we can actually find the overall length of the amount because those parts would be corresponding. Questions on this here? Okay, I lied. We're going to do this last one here. Explain how the measurements in the diagram. Explain how to use the measurements in the diagram to find the distance across the pond. Well, it's congruent to itself, yes? Or not to itself. We have vertical angles. So what do we have here? I have a side, an angle, and a... So would these two triangles be congruent to each other? Right. Since these two triangles are congruent, it means that AD, BC, well, by our CPCTC, because we could say that triangle AED is congruent to triangle CEB by our side angle side, so we can say that these two are congruent. So what would BC be? $57 yards. Because AD and BC would be congruent to each other. Yes? But that's it. Because most of everything that we've been doing here is just using the fact that can we show that the two triangles are congruent? If we can, then we can use CPCTC to say that whatever we're wanting to prove is true. Now, if we can't show that the two triangles are congruent, then we can't say the parts we want to be congruent are also